Okay, thanks very much, Neil. Welcome everybody, and welcome everybody on Zoom. It's great to have a few people on Zoom this evening and a few people at the hall here at East Bendigo for the Bendigo Amateur Radio Electronics Club. First of all, thanks very much for Craig for being the Zoom and video operator. It's fantastic what Craig has been doing. And Swoop Aero is a company that specialises in providing logistics and critical things like medication and medicines and things like that, using the latest aircraft, the latest drone technology, and including, they'll be talking about 3D printing and communications and all the technology that goes towards making these drones. Without a further ado, I'll hand it over to Michael from Swoop Aero to introduce the team, and we'll sit back and relax and have a very interesting presentation. Thanks. Over to you, Michael.
Cool. So we'll just do a mic check. Can everyone hear me? Cool. So thanks very much for the opportunity to be asked to come and tell you a little bit about Swoop Aero. I'm Michael. I've been setting this up with Graham for the last week or so. I'm the head of production here. I've got Josh here, who's our CTO, our Chief of Technology, and Ashini, who is one of our flight test engineers. So we all represent a different field of the company. So hopefully we can all, talk a little bit about our domain and what we all do. So I'll start with Josh. He's going to give us a quick rundown of what, the quick version of the founding story of Swoop, as he was the employee #1. So I'll hand it over to him, and he can give you a rundown.
Thanks, Michael. Hi guys. I'm Josh. I'm CTO and one of the co-founders with my co-founder Eric of Swoop Aero. We founded Swoop Aero in 2017 to change the way the world accesses critical medical supplies by bringing access to the air to everyone. So kind of talk you guys through what that looks like and give you a bit of an idea of our journey to here, and then that'll kind of include a summary of our technology, and I think Webby's kind of arranged we'll have a bit of a Q&A, and you can ask questions everywhere. I'll might have to cut that off in a few places just with IP and a couple of places where a bit cagey about our technology with competitors, but try and be as open as I can. So we founded in 2017 when I met Eric Peck, my co-founder, and we met when Eric was trying to build a drone logistics service to carry people between the Melbourne CBD and the airport. And he reached out to me as a technical consult, and I kind of told him he was dreaming, and there were kind of some technical limitations there. But that kicked off a friendship nonetheless, and he kind of continued to pursue that, and I did some consulting work with him. But eventually that business kind of ran into the technical hurdles and slowly fell to the wayside. But that kicked off a really strong friendship, and over the next year or so, we were back and forth, and eventually Eric, through his consulting work, got asked the question whether it was feasible to move chemotherapy medication from the Sydney CBD out into rural New South Wales. Chemotherapy medication kind of has these unique challenges around logistics because it degrades over time. It has some radioactive isotopes and things in it. And we had a bit of a chat about it between us, and Eric went back to that group and he said, yeah, it's very possible, but right now there's not really a commercial service that you can contract to and he'll be able to deliver that to you. So through that conversation, we kind of identified there's a real gap in the market there. And we took that as a really strong signal and started having to put, we founded the company and started having to play around with technology to see where we could go in that space. The first 6 months or so, we're kind of playing around with a whole heap of different vehicle plan forms and technology elements. We made some cool like tail sitter VTOL aircraft, and we were playing with patents and like some unique technology elements. And then about 3 months into that process, there was a tender from UNICEF to contract to deliver the vaccination program in Vanuatu using drones. UNICEF had kind of targeted that specific application because there's a whole heap of significant challenges with vaccine distribution in Vanuatu. It's complex because it's an island group with a relatively like well-dispersed population. There's some challenges there with integrating with communities and educating the people on the ground. And like the healthcare system there's really, there's well-trained nurses in each village, but there's no logistics support for transport for those nurses to get back from the villages, back to the hubs to be able to pick up any medication or vaccinations that they don't keep on stock in the villages. So like the challenge that goes along with that is when these nurses are leaving the villages to spend 2 days walking to a health centre to collect medication, it means they're not in their village being there able to deliver healthcare if someone has an emergency medical situation. Like, you know, if someone has a broken leg, they're like in danger of dying because they're unable to get medical treatment for 3 or 4 days while the nurse is out of the village. So we were really inspired by that situation. Like we thought we had the technology that was able to help these people. And where we were at the time with our development was still in the development phase of like trying to get these vehicles flying that we're trying to patent. So we kind of put that aside, focused our technology more on a more well-established technology with the what's called quad plane, where you kind of just bring together multi-rotor and fixed wing drone technology. There's kind of some open source code base and existing technology platforms there that we can leverage. And so we bid on that project. Eric and our first couple of employees all got together and we put together a really strong tender application that says, yeah, look, we're going to go out there, we're going to go integrate with these communities, we're going to educate guys on the ground about how this service is going to work, and we're going to build, and the technology is going to be that's going to be able to deliver it. So we won that tender and then immediately recognized that we had about 2 months to build all this technology that we said we already had. So pulled in Michael a little bit, pulled in some other friends I had in this technology space who knew a little bit about this open source technology already. And we had two or 3 months of very long nights and like very intense technology development to build out our first Kookaburra aircraft platform. I think once we get a bit further into this, Michael will give you a look at it. It's right there, 2 meters to the side of the camera, and we'll give you a bit of an overview of what that technology looks like. But we kind of pulled in 3D printing to be able to produce the hardware quickly. We pulled in some open source electronics platforms, and then we just like very quickly made prototypes, and then went from those prototypes to make 3 or 4 copies of those prototypes to be able to go and deliver this service. So we took all that stuff over to Vanuatu in 2017. We had like, 4 or 5 prototypes and 3 or 4 people at that time, and effectively spent 6 months running around in the jungle in Vanuatu running a drone logistics service. So there's some very cool stories in there. Like my favorite one is Nurse Marie was in this village. We got a call at the health centre saying she needed a delivery of oxytocin, which is like a medication for post you've delivered your baby and you're having bleeding issues. So it's like a life-threatening condition. Traditionally, she would have to walk 2 days to the health centre to collect that medication and walk back. And like in that time, obviously the patient is like at a significant risk of dying, and she's away from the village. So if anyone there has a significant health implication, then like they're really in trouble. And we were able to deliver that medication to her in just 45 minutes from when she called the health centre. So it's like, it's really providing this access for these communities to like the same health care that we expect, you know, in Australia, growing up in Bendigo or growing up in Melbourne. So that experience like was very valuable to us, obviously all as individuals, but it also kind of really informed where we wanted to go with developing the technology and developing the company. So we came back from that trip, we kind of continued to sustain that network, and we focused here continuing to develop the technology, like taking the learnings from that experience. So like we needed to make the technology more robust, we needed to make it more easily manufacturable so we could get more units out there. And we needed to like continue to build this platform that would be able to support operation in these remote communities. So where we've taken that now is like we've focused on that manufacturing aspect, and we've built a cloud platform around those aircraft that allows us to maintain knowledge of where the aircraft is at with maintenance and performance, and access to all the aircraft's flight logs as it generates data while it's flying, all remotely while these aircraft are operating in these communities. So there's like some synonymous stories with Vanuatu where we've deployed in DRC and that was a real adventure, and we've deployed in Malawi and that was a real adventure. And now we're in this position where we've grown these networks, we have very sustainable technology that's operated by community members on the ground and operated in Malawi, DRC, Mozambique, UK, and Scotland. We have a platform model customer over there, and we're working with regulators here to launch networks in outback Queensland and in New Zealand. So those networks that are already established provide more than 2 million people with access to critical medical supplies, vaccinations, and access to pathology services now, who otherwise don't really have access to those things. Hopefully that's a good introduction. I'll hand over to Michael to talk a bit about manufacturing, and then
yeah, so that like those couple of stories coming out of Vanuatu pretty much sum up like what we're aiming to do as a company, I guess. So yeah, give people access to healthcare pretty much who don't have the luxury of having it here like we do. So we've got I put the webcam on a portable, like an external one, so I can show you all this. We've got a plane set up here, like one of the current models we're flying in Africa at the minute. So we'll give you a demo and a look around it. So this here is, sorry, we're gonna move that chair machine.
Yep.
So this here is one of the aircraft that we operate in. We're operating these in Africa, and this is our current. This is pretty much our workhorse at the minute. This does most of the flights we've done so far. So I'll go over some of the features of it. So it's predominantly built from carbon fiber and PLA plastic, which our 3D printers use. So, we have a fleet of about 18 3D printers that we print these things on, and it takes approximately 40 hours of 3D printing to print one of these drones. So that gives us about a plane per week, and including weekends, we can get a bit of a buffer and end up producing about 2 planes per calendar week worth of 3D printed parts. So our aim for the last 18 months has been to produce 2 aircraft per week, it's been an ambitious goal, but we've got there. We've started hitting that lately. Like there's been a lot of speed bumps sorting out our manufacturing processes and getting the resources we need to build them. But now it's all kind of settled down, and we have a fairly good process for it all. So, so most of the airframe itself is built from PLA and carbon, and that's all done in-house. And then all the components, most of them are outsourced or pre-made to some extent, so that the manufacturing that we do here in Port Melbourne is mostly assembly work. So all of the wiring looms, all of the components, all of the printed circuit boards are outsourced, designed in-house and manufactured elsewhere, and all the assembly happens in Port Melbourne. So yeah, so that's a pretty good overview of the manufacturing. It's yeah, that's the drone. So I'll hand over to Ashini.
What we basically do after drones come out of the workshop is we take it out to what's called flight commissioning, which is essentially we fly the drone for 4 cycles, make sure all the hardware and software integration is as it should be before we ship it out to operations, say in DRC, Malawi, Mozambique, or the UK. So I'll get Michael to put what we call the pod on the aircraft, so you can see how the aircraft kind of boots up or like comes alive. It'll shortly give an audio cue saying booting up, please wait. Huh? It's commissioned. So you can see the lights on both the wingtips are flashing, which means all the avionics in the system and everything is kind of booting up. All right, while it does that, I'll quickly give everyone an overview of the pod bay. So that's where we store all the cargo. The drone can carry 3 kilograms of payload, be it vaccines or sample lab reports or blood samples. And that's where all your payload would go in. Sorry, that's taking a while, guys.
So normal procedure would be the nurse would come out from the hospital where there'd be a drone waiting, load the cargo in. There would be a pilot remotely preset a route onto the drone of where it's going, and all the operator has to do is come and push the button, and the drone would take off automatically. It'll count down from 10, take off, and fly to the destination with no input from the healthcare worker who's loading the drone. I'm going to try and reboot it. It's having a bad day.
So we've got the system which we call the remote pilot system. That's what all our pilots across the network use. So what you basically do is you log into the system, you boot the drone up, you load the route, which is a pre-planned route, and that goes through to the drone, and the drone's like, all right, I've got the route. It just waits for the pilot to say, all right, I'm ready to fly. And like Michael said, it's basically a matter of just pushing the green button and it's on its way.
Yeah, I think Ashini's undersold herself there a little bit. She kind of runs our kind of flight test and commissioning process up at Murchison. So there's kind of some complex elements there around ensuring as the vehicles come out of production, they've been gone through their bench commissioning process, and then ensuring they go through their flight test procedure. And also, as we're developing new technology items in the technology team, ensuring that those are tested robustly and ready for production, which is where we're deploying that software remotely to vehicles in the DRC and Malawi, and supporting that software from Australia. So just to kind of talk through the technology elements that we've implemented to kind of build out this technology stack. I'll give you guys a quick overview of the hardware if you like, and then we can give you an idea of like how that plays through to our cloud platform and operation stuff that supports that. Do you want to try and log into platform and see if we're playing up?
I will, yeah.
So on the technology side, on the hardware side, Ashini's already given you guys a demo of the pod coming on and off. So we try and break up the hardware into what we call our pod and shuttle architecture. So the pods contain the batteries and the vehicle payload. So what we're trying to maximize there is having the high CapEx components of the system in the air, providing value to the business as often as possible. So while the pod's off, having its batteries charged and having new payload loaded into it, we've developed a hardware block there that's called a pod dock, which charges the batteries and gives the user information about which payload needs to be loaded into there the next go out in the network. So while that's charging the shuttle, which contains all of the high cost elements like motors and flight controller and communication systems, is always up in the air, providing value to the business. To kind of talk through what the rest of that looks like is in that center section under the pod there, we have like a flight controller, which runs the real-time operating system that takes care of all of the aircraft sensors and actuators. So that's like accelerometers, gyroscopes, barometers, GPS receivers, LiDAR. What else have we got? Compass, and that kind of gives the vehicle
Communications.
all of the information about where it is in the world, and it builds those together into an extended Kalman filter model to give itself very accurate, like a very accurate state estimate about where it is and how it's flying. And then it uses that calculation along with the navigation and the position estimate algorithms that we've built to calculate what it should be adding to the outputs, which is like motors, servo actuators for control surfaces. That's kind of it for the autopilot. And then if you haven't seen a quad plane platform like this before, it's very much just like combining both a multi-rotor and a fixed wing aircraft platform. So the 4 black motors that you see on top of the booms there are like hover motors that function in the same way as a DJI that you buy from JCar and fly around and take photos of your friends from your backyard. So that allows the aircraft to take off and hover in place. And the way we run the system is those motors hover the aircraft up to about 40 meters altitude, and then the forward propulsion motors turn on, accelerate the aircraft forward. And once the aircraft is at about 100 kilometers an hour forward speed, the wings are making a left lift that they're holding the aircraft up, and we can turn the hover motors off. And that's a much more efficient mode of flying and gives us much better range performance. One of the little like technical implementations that I'll give you guys a window into of how we've implemented that is we play around with different battery chemistries. So as you might know, it's like some battery chemistries have very high energy density, which is like the amount of energy they store per unit mass. And you can kind of trade that off with different battery chemistries for very high power density, which enables very high output power per unit mass, but those things aren't necessarily interchangeable. So we have two different battery systems in the pod. One, a very high power density pack, is connected to the hover mode system, and that allows the aircraft to lift itself off the ground. And then once it's accelerated into forward flight, we're utilizing the high energy density system to power the forward motors. That's kind of one of a few unique technology elements we've built to kind of give us the performance we need. So what that looks like is we're able to put 3 kilos in the aircraft. It can take off in hover, climb to 40 meters, accelerate to 100 k's an hour, and fly more than 100 kilometers in that mode before it needs to transition back to hover and land. So that gives us a very large distribution radius for our logistics networks. The other elements in there are the companion computer, which is like an embedded processor we have that's able to run like a Linux operating system and Python scripts and stuff on top of that. And that communicates directly with the autopilot, kind of gets the critical flight data like airspeed and GPS location and altitude, and distributes that information across our communication buses, which are like, we have a SATCOM comlink, we have a 4G LTE comlink and a Wi-Fi one. And that allows us to get the data from the autopilot back to our cloud platform, which Michael's pulled up on the laptop here. And that's a service we run on AWS, which is effectively the pilot's interface for flying the aircraft. So do you want to try and get this up on the screen, Ashimi?
Yeah.
Can you see that?
So I'll go through RPS and
Sure.
ops. So this is the RPS platform, or RPS stands for Remote Pilot Station. This is the web interface we've built to communicate, pilot, and manage our fleet of drones. So at the minute here, the only one that's currently booted in this region is the aircraft we have here on the table. And you can see it's located at our head office in Port Melbourne. The aircraft I've currently put in maintenance mode, so we can go in and change settings and inspect the firmware on the aircraft. But yeah, another tab I have here is to come to the fleet management system that we use. So here we can see all the aircraft we have and the status of them all, when their last flight was, and we log all kinds of data about every flight that happens all over the world. And we use that data to improve things like efficiency and yeah, just having all this data on the aircraft is really helpful. So, and that extends to things like our the pods that we put on the aircraft. We track those separately. The chargers, or the pod docks we call them, that are integrated into that system, we track those separately as well. Even down to each component on the aircraft has this unique ID number, and that can be tracked, like hours can be tracked on individual components, so that we know that if batteries, for example, have done a certain amount of hours, we can have a flag come up and notify the pilot that you know, they need to be changed within the next X amount of time. So that's our fleet management system, our RPS system, and our what's the other one? Our pilot screen.
We might have a...
Do you want to talk through our plan?
Sure. Yep. So we've also got what we call route planner. That's the interface where we build all our routes. So all across the world, you just select where you want to build your route, and you go in and define all your location properties. So your latitudes, longitudes, altitudes for each of the locations. So I can show you, that's one example location you do. This is in DRC. to set all your coordinates and the parts you want to take out and into all your locations. And it's just simplified, as in you just map out the segment you want to fly. So if it's just from A to B, you just go in and drop in what we call a waypoint. So you drop in all your waypoints from where you want to fly to your destination. And it's just a matter of combining all your locations and your segments to create a route. So this platform is directly linked to our operations platform. So once a route planner plans a route, what we call a route authorizer just cross-checks the route and says, all right, this is good to go, this is good to fly. And it directly links it and uploads it onto our operation platform where you can load it onto the drone. So it's been simplified into essentially 3 simple steps. That is our planner platform. Just we got anything else to add, or we're happy to take any questions you guys might have?
Yeah, I think that's a good overview of our RPS system. So yeah, now you've had a brief rundown of the systems that fly the aircraft and how we manage them. We might go to some questions. So cool, yeah. So if anyone's got any questions, we'll do our best to answer them.
Yes, I've got a question. I was wondering, when I was younger, I was working at flying school, so I'm familiar with normal planes. And these days, I like for enjoyment to fly a DJI. And I was looking at your drone, and I understand what you're talking about it as being a combination between a multi-rotor and a conventional lifting surface in the wing. But I couldn't see any ailerons or rudders. I was wondering how you achieve directional change. Are you using differential thrust between the front propellers, or are you tilting it using the rear propellers? I wasn't sure how that was working for turning in angles. Over.
That's a good question. The webcam we're using probably doesn't have enough resolution, but we do actually have control surfaces. I'll get the camera up closer so you can see them. It is actually like a traditional aircraft. So these ones here these are our control surfaces on the wings, and on the tail there's some there as well. I'm not sure if you can make those out, but we have full dual redundant ailerons on either side of the aircraft, along with rudders and elevators on the top there.
Sorry, I was off on a wrong track. That didn't show up until you went closer on the plane, and it looked like a solid wing. And I was trying to figure out how you were achieving directional change, but that answered my question. Thank you.
That's all right.
Yeah, I think one of the things to highlight there as well is like obviously with an autonomous system that we're deploying in the way we do, I guess these hardware systems are operating in very remote regions with only limited support capacity from the technology back here in Australia. Like we've got some very skilled guys on the ground that we've trained from the local communities. But regardless of that, once the planes are in the air, they're very much on their own as autonomous systems. So one of the things we've implemented there to mitigate the risks of like an aircraft landing in the middle of the jungle in Africa is these redundant control surfaces. So rather than just have a single aileron, they're split into 2 separate aerodynamic elements that are each driven by an independent actuator. So that if we have an actuator failure, there's enough actuators left in the system that the aircraft is still in control and can finish its mission. And that kind of makes sure that we always get the hardware back to somewhere where we can get access to it and fix it.
Yeah, that's fair enough. I've been to Vanuatu a few times, and as you mentioned, it's an island, chain of islands. Are you flying over water as well, or?
So when we first set up networks there, we had networks in Erromungo, which is I guess the next island south of Port Vila there. And so we distributed from South River, which is like on the west side of the island there across the whole island. That worked out well because there's like the civilian airport there, where we can get manned aircraft in, get supplies into that hub, and then distribute across the rest of the island with our drones. The second network we set up there was in Epi, which is like north of Port Vila. And similar thing there, there's like a little bit larger, more established airport just in one village on the west side of the island. And we're kind of hiking from there up to the top of that hill next to the airport to distribute vaccines out from the health centre there out across the rest of the island.
That raises an interesting, sorry, I don't want to hog the question, but that does raise an interesting point. You were talking about the airports there, which raises the issue of controlled airspace. I know that developing nations may have a somewhat more relaxed attitude to unmanned aircraft, but you did raise the issue of in negotiations with the Australian government, which I assume means CAPA, they're not necessarily the most flexible organisation in the world. I was just wondering whether you were having any luck.
Yeah, I mean, it's probably the inverse of what you've projected there. Like we found in the developing nations, it's relatively easy to work with the regulators because they can really see like the value add of what we're trying to do on the communities there. So they're kind of willing to make, like, what it comes down to is they're willing to make the time for us to work through to a safe solution to enable us to do, roll out the technology in those regions. So when we're working in Vanuatu next to the airports, like we'd worked through with the Vanuatu aviation regulator, and what it really came down to is we just had an AV-band radio at our hub where we were operating from. We made sure we're monitoring that band, and like if anyone was coming into the land of the airport, we just let them know that we're there and we're operating kind of in that region. And it's very simple to deconflict. It's a little bit more complex in the DRC and Malawi, where they're larger population centers, and it's a little bit more complex as far as like aviation traffic and all the other things going on there. But regardless, it's a little bit more of a, I guess, expanded version of the same process where we just kind of work through the concerns that the regulator have, work through how we're going to resolve those issues, and then like go out there and do things. What we've seen in the developed markets is it's very much more like we need to work out how to fit into the framework that government entity is enforcing. So it's a little bit more complex as far as like it really becomes like a political negotiation exercise, but we're kind of making good progress there now. Like we have regular operations in Australia for flight test and demonstration networks. And like we're looking to kick off those established like, extended time period logistics networks in the next 6 months or so.
Okay, thank you for your answers. It's much appreciated.
It's Craig here at the Clubroom Hall. Had a question from the floor here asking, you mentioned 100 kilometres range of the aircraft. Is that 100 kilometres out and then can it go the 100 kilometres and return, or is that a maximum flight duration? I guess then do they recharge it at the destination to come back?
Yeah, so it's the true range metric is 130 kilometers of like air distance. And so what we say, like the way we project that into a logistics range is it can go 100 kilometers between like hub locations where we have charges stored in any weather conditions. So we set the maximum operating wind limit at 50 kilometers an hour, which is actually really fast. That's sort of like storm type weather. And so it can achieve that 100 kilometers range flying in 50 k's an hour of wind. Obviously, like if you have a plane up here flying in the air and it's flying in a 50 kilometer an hour headwind, it takes longer to get there and it can't quite go as far before the battery goes flat. So yeah, we specify 100 kilometers between hub locations. So that either looks like most of our networks are hub and spoke distribution networks. So we'll have all of our chargers and vehicles stored overnight at the hub, and they'll distribute out to spokes that are within 50 kilometers of that hub and be able to go there and back. And then we have some locations in DRC and Malawi where we've also distributed network hubs where we can fly 100 kilometers to that hub. They'll do a pod swap there, and then the aircraft will go on out to a spoke even further away, come back and bounce back through that network. And so we kind of utilize that as the framework that we can use to build a network that covers most of the country of Malawi now, and kind of expanding through DRC. Like DRC, I think we currently cover about 30% of the population, and that's expanding towards the capital city there.
And had one other question from the floor here in the hall, just asking whether the aircraft designer has an aviation background and you know, a pilot's license.
Well, I guess the aircraft designer really is myself, and with some contribution from Michael and Ashini with flight test and production methods and things. I don't really have an aviation background in commercial aviation. I had a couple of years where I was racing drones with Michael, which is about the closest thing we got to. But my co-founder, Eric, had a very successful career with the Australian Air Force flying Hercules. And we kind of, you know, through his network very quickly brought in some flight check captains and chief flight test pilots from the Air Force. So that kind of brought together that knowledge from, you know, the very low level understanding of the technology and how to implement that into a commercial product, as well as that aviation knowledge of how to then take that implementation and integrate it in an aviation environment and kind of take it to commercial success.
Could these aircraft be scaled up?
In physical size, yeah. So we have a new generation platform that's about to come online that's about twice the weight of this one. We've kind of primarily used that extra mass to get more performance as far as range and flight speed and things. There's also some other players in the market that are looking to do like deliveries in the hundreds of kilo ranges, and then other players who are looking at doing like, you know, kind of 2 and 4 seat commercial aircraft. The feasibility of that, like, I have technical concerns about, but they're certainly getting market traction and funding. So there's definitely people out there who consider it very viable to scale up this technology.
Thanks.
You got any more questions from the floor?
Communications. So has there ever been any requests or thought of using the drone technology for temporary repeater communications, as in flying a repeater, which can be quite small now electronically, putting it in a drone and using it for communications?
Yeah, we get like, there's certainly been lots of discussion kind of near or around that topic. Like the one that we've actually done in like commercially, you know, had some profit from, I guess, is one of our platform model partners in the UK has partnered with Vodafone, and they fly around the. Oh, sorry, we're just going to mute. I was getting a bit of echo back. Yeah, thank you. Yeah, so they fly around a 4G like receiver analysis type piece of technology that records signal strength and has a GPS receiver to start building out a signal quality map for Vodafone. It's kind of like, it's an interesting use case, given like received signal strength is obviously very different at 400 feet off the ground than it is you know, for a consumer for Vodafone on the ground. But I think they're starting to look at, you know, how their networks apply to really like these drone logistics platforms in the future. That's the one that we have in operation. And then we do kind of frequently get approached by, we're looking at fire services in New Zealand, and they're looking to do, like put one of our platforms up over a fire in an emergency situation, have like video feedback from the aircraft to inform them about where the fire is, and then use it as a repeater for their, you know, like handheld voice radio to help coordinate how they're fighting the fire. So there's certainly niche applications there. One of the limitations we find is, like, obviously we push down that track from a commercial viewpoint, but really our platform is designed for range rather than flight endurance. So there's other platforms out there that can fly for a very long time but not get very far, whereas we can't really fly for as long, but we get much further and can carry more payload to get there. So
yeah, thanks very much. That answered my question perfectly. That's great that they're looking at using it for that type of communications, because I have had a background in fire emergency communications. Another question is, I was watching a documentary today on protecting wildlife in Africa on reserves, and of course it's very, very dangerous, and they have military operations pretty much, and the rangers basically risk their lives protecting wildlife from poachers. Has there been any thought or requests on helping them to, well, maybe with surveillance and so forth, with this technology in regards to poaching in Africa or other nations?
yeah, so like right now we haven't really been approached or like have any direct operations in that application. Like, I'm kind of aware that there's groups out there who are really focusing development of similar technology to ours for that application. But like, my understanding is, I guess kind of the disappointing reality of it is they've run up against the reality that most of these groups are kind of NGOs with limited funding, and it doesn't quite translate through to a sustainable operation, in the sense that they can get donor funding to go out there and do a trial and maybe fly for a couple of weeks and show that it's borderline feasibility, but can't quite fund that through to developing out technology that can sustain that, and then, you know, have the funding there to continue to do it for an extended period of time. It's something I'd be very interested in from, you know, a moral standpoint, if we could sustain that, but I think that's kind of dependent on one of those groups approaching us. Okay, cool. Thanks very much for having us, guys. It's certainly been enjoyable to talk to you, and like the questions we've had back have been great fun to discuss. So really appreciate the opportunity.
Oh, am I on? Oh, yeah, thank you very much, Michael and the crew from Swoop Air. We very much appreciate your time this evening, and it's been very educational, and I'm sure we've all learnt a lot. I know I have, and I know our people on Zoom would have appreciated it too. So on behalf of Bendigo Amateur Radio Electronics Club and members from other radio clubs that are on Zoom, thank you very much for this evening.
Thank you for having us, guys.
Cool, yeah, thank you very much for having us, guys. It's been fun.
Thanks very much, everybody, for joining us on Zoom. How many do we have on Zoom this evening, roughly? 15? 14, that's great. Thanks, everybody, for joining us on Zoom. Look forward to next time. And let's keep the communications up between the clubs and what we're doing. And it's been really good using Zoom. Oh, sorry, there's a red light. So that's about it from this end.